tonight. Firstly, and exciting as always, JAMB tutorial class on chemistry. So today we're talking briefly on basic of naming compounds and balancing of chemical equation. Yes, these have been a problem to many students who find it very difficult in naming compounds. So as you follow me to the end of this video, you will get to understand everything you need to know, alright, about naming of compounds and equally how to balance chemical equation. So before I go ahead to give you some compounds and name it to you, there are some things you need to know, alright? Before you start naming compounds, you need to know some things, alright? Which are 1. We have the oxidation number. 2. We have the ions. 3. We have the radical. Then 4. We have the velocity. Alright, so these 4 terms, they are very important things you must know, right? In order for you to name compounds. Now, what is the oxidation number? Alright, elements are divided into metals, non-metals, and metals. Alright, so there are some set of elements that possess a positive charge, and there are some that have a negative charge. Alright, so for metals have positive charge, non-metals have negative charge. So from there, the oxidation number is the charge. Yeah, the charge that is given to an element, alright, is known as oxidation number. Alright, the charge given to an element or assigned to an element is simply known as oxidation number. Then we have the next one here is ion. Yes, ion. There are some elements that possess a charge, be it positive or negative charge. Alright, so such elements that possess a charge, be it positive or negative, is simply known as what? Ion. Alright, so atoms and elements comes together to act as a single unit and possess a charge. They are simply known as radical. You see it now. Then we also have the what? We also have the valence. Yes, valence is the combining power of elements. Let me give you a quick table, okay, of this. Here we have the ion, example of an ion. For instance, we have sodium. This is sodium. Sodium is Na+. Yes, sodium is Na+. So it says situation like this. Sodium possesses a positive charge. Alright, and its oxidation number. Oxidation number sodium is +1. So this charge that is assigned to sodium is +1. Here we also have the valency. So the valency has nothing to do with the charge, either be positive or negative. It's more concerned with the figure. So here we have 1. See that? Now the next one, we also have that ions kind of right minus -1 and 1. Okay, we also have K+, which is +1 and 1. We also have Ca2+, which is +2 and 1. We also have Mg2+, okay, Mg2+, which is +2 and 1. We also have Ne2+. Sometimes it could be Ne3+, which is sometimes +2 or +3, depending on the compound in which it is found. Then we have 2 or 3. So these are just few examples, okay, of a ion, oxidation number, what, and valency. Now when it comes to radicals, we also have some examples of radicals. Radicals, the oxidation number and its valency. Yes. So we also have OH- is a typical example of radical. This is called hydroxide. That is a combination of oxygen and hydrogen. See, 2 elements and possess a charge, negative charge. So here we have -1 and 1. We also have NO3-. See, this is a combination of nitrogen and oxygen. We also possess a single charge, and this is called triazoxide nitrate 5. Yes. So you also have -1 and 1. And we have SO4 2-. Yes. SO4 2-. Here is sulfur and oxygen. So from here, the name of this radical is extra also, okay, 6. So from here we have minus 2 and 2. So I believe you understand this. Now, I have a simple thing about these basics, okay? So take your time, study this table, know the charge, the process for the ion and the radical. With this, you can give the formula to a compound, or you can give the name to any compound at all. So now, we waste most of our time. We're coming down to IUPAC. Yeah, this is a very simple and easiest system, right, of naming compounds in chemistry. It's known as IUPAC. IUPAC is a system of chemistry, alright, that is used in naming of compound, where I stand for international, I for international. Are we together? Alright, very good. We also have U for union. E is for pure. Then we have A and bind. Then C is chemistry. Alright, so that is the full meaning. Alright, so now we name some compounds, alright, using this IUPAC system. Okay, so we're going to start with a very simple one on your own, which is H2O. H2O is what? Thank you very much. Water. H2O is water. Then the next one here is CO2. Okay, now this is CO2. I believe in biology, we say it's carbon dioxide. Some chemistry may also say it's carbon dioxide. That is the correct name, okay? But in IUPAC have a system of giving this compound name. IUPAC will say that this is carbon 4 oxide. How is it carbon 4 oxide? Now, under IUPAC, when oxygen is reacted with one element, oxygen is simply known as oxide. Alright? This oxygen is being known as what? Oxide. Then, how come this 4? It is gotten from the what? From the 4 is the oxidation number of carbon. Alright? This 4 is the oxidation number of carbon. In our next class, I'll give you a calculation on oxidation number. Yes, a detailed explanation of oxidation number. Then from there, you understand why 4, okay, is the oxidation number of what? Of carbon. Now the next one here is carbon 3. Okay, now we have 3 compounds here, 1 atom of calcium, 1 atom of carbon, and 3 atoms of oxygen. Now under IUPAC, the important thing you should take note of in naming compounds, probably that involve 3 elements. The first thing you should do, the first element here, give it its original name, alright? Its exact name. This is Ca. Ca represents calcium. Alright? Ca represents calcium. Okay, having done that, then check the third element. We have 3 elements here. The third element, alright? The third element here is oxygen. But how many atoms of oxygen do we have here? We have 3 atoms of oxygen. We use tri for 3, di for 1, then tetra for 4, and so on. So this is what you use, okay, in naming of these compounds. So now we have 3 atoms of oxygen here. So we're going to use tri. Tri represents 3, di represents 2, tetra represents 4, penta 5, and so on. So now we have 3 atoms of oxygen here, so we're going to say tri. Okay? Now remember, I told you when oxygen is with 1 element, it says oxide with 2 elements, as you can see, use also. Have you seen that? Also, when it's reacting with 2 elements, not just 1 element, you use also. So we have calcium triazole. Then the middle element here is C. C is for carbon. But IUPAC will tell you to always say the middle element with ATE. ATE. So from here, you have carbon. See, this is carbon. That's why we this suffix, okay, ATE. So that becomes carbonate. 4. How is it 4? I told you in our next class I'm going to explain the decision number, okay? How to calculate the decision number of an element in a compound. From there you have a detailed explanation on how to arrive at this figure. And please, under the name of compounds, don't use numbers, use Roman figure. Okay, use Roman figure. Alright, so that's it for Capital 3. Now let's come to the next one. This is number 3. Okay, we also have now 2SO4. Okay, let's do this. We also have the compounds here. Like I said, the first element, thank you, you're following. The first element, which is sodium, give it its original name. Okay, so this is Na, sodium. Okay, this is oxygen, 3 atoms of oxygen. It is triazole. Then this is nitrogen, N for nitrogen. I know you should be asking. It should have been nitrogen, right? But no. It also ends ATP. Okay, but in this case it is nitrate. When nitrogen is in its combined form, we don't call it nitrogenate, we call it nitrate. So here it becomes sodium triazole, nitrate. Then we have 5. Okay, we have sodium triazole, nitrate, 5. Very good. So now let's come to the next one. This is sodium, alright? This is sulfur, this is phosphorus. We also have 3 elements. Yeah, so this becomes sodium. Like I told you, this is 4 atoms of oxygen, and when it's 4, you use what? Tetra, alright? So here we have sodium tetra, oxygen also. Okay, so this is sulfur, alright? This is sulfur. So this should have been sulfur, right? But no, sulfur is combined form. It's simply known as sulfate. And this is simply known as sulfate. So here it becomes sodium tetraoxide. Sulfate. Okay. So very simple and clear. So I believe you understand what I've done with these few examples. Okay, just one more. Then we also have K2 CO3. Yes, we also have K2 CO3. Okay, so this is what? Potassium. So in this K represents potassium. This is oxygen. 3 atoms of oxygen becomes triazole. And this is carbon. Okay, carbon still remains carbonate. Okay, so carbonate. Right, very good. So that is it. In our previous class, we talked about the decision number, how we arrive at these figures you are seeing all over this place. Then I will add some chemical equation to that next class, which is part 2 of this. Thank you, and please do not forget to like my videos and subscribe for more exciting and interesting videos on JAMB tutorial class.